friends, let's understand continuous charge distribution. You already know that there is a quantization of charge. When charges are in a small amount, that is countable, then there is quantization of charge. But when the charges are huge in amount, that is uncountable, then the charges are considered as continuous charge distribution. So, what is continuous charge distribution? When charges are huge in number, then the charges are considered as continuous charge distribution. It is of three types. One is said to be linear charge distribution. Number A is said to be linear charge distribution. Here charges are distributed in one dimension. Charges are distributed in one dimension, that is in a line, maybe curve or straight line, that is in a line, straight or curve. To understand this, let us consider a wire having plus charges uniformly distributed. Let us have a section of the wire DL, small section. In this DL there is charge dq. There is charge dq. So we will take here linear charge density. So here is a word known as linear charge density, symbolized by lambda, and this is equals to dq charge upon dl length, charge by length. So its SI unit of lambda equals to coulomb per meter. So this is said to be linear charge distribution. Number B part is said to be surface charge distribution. Here the charges are distributed in two dimension geometry. So charge are distributed in 2D, that is on the surface of the body, that is on the surface of the body. Here there is a word known as surface charge density. So the new word is surface charge density, symbolized by sigma. To understand this, we require a surface area of any shape. In this surface area, let us take a small surface having charge dq and having surface ds. So sigma is equals to dq upon ds, that is charge per unit surface area. So SI unit of sigma is coulomb per meter square. Number C is said to be volume charge distribution. There is said to be volume charge distribution. So you have volume charge distribution. Here the charges are distributed on the volume of the body, entire volume of the body, that is in 3D. Charge are distributed in 3 dimension, 3D, that is in the volume of the body. Here is a new word for you, that is said to be volume charge density. So the word is volume charge density. Rho is the symbol. To understand this, we required a body having a volume, that is 3-dimensional body, having charge. Let the body have charges. Here consider a small volume. This small volume is dV, having charge dq. Then you have dq upon dv is said to be volume charge density. So it is charged by volume, so coulomb per meter cube is the SI unit. SI unit of rho is coulomb per meter cube. Thus you have learned what is continuous charge distribution. When charges are huge in amount, that is they are uncountable, then the charge is said to be continuous charge distribution, and it is of 3 types: linear charge distribution, surface charge distribution, volume charge distribution. Let us have a numerical question based on this. Question is, here we have a ring. A ring have a uniform charge. Let a ring have uniform charge. And this is the radius of the ring A. This is the axis x distance apart. O point P. What is the electric field at point P? This means that you have to find electric field at point P due to this linear charge body. To find the electric field, we just take here a small length dl, having charge dq. So this small charge dq produces electric field, and since it is positive, so the electric field moves outward. So let us take a tangent from here and join the point P and pass the tangent away. In the same way, on the opposite side, let us have another length here. The length is dl, having charge dq. Let this point is A, this point is B. Let us again have a tangent and join the same point and pass it. Now this dl at point A produces electric field here known as D. In the same way, this dl at B produces electric field at point P, which is again said to be dE. Let us resolve dE into 2 components, cos component and sin component. For that, take a perpendicular here, extend this line. So this angle and this angle are same, which is theta here. So this is same angle theta. So dE is resolved into 2 components. One is said to be dE sin theta, other is said to be dE cos theta. Same for this dE also, dE sin theta, and you have dE cos theta. Let the distance from A to P is r, and r is equals to x square A square whole power root. This means that power is half. Now from the diagram it is clear that electric field dE sin theta and dE sin theta are equal and opposite. One is moving upside, other is moving downside. So they are equal and opposite, they cancel out. But at the same time, dE cos theta are moving on the same direction, having same magnitude, so they add up. So two diagonally opposite side D add up to give you 2 dE cos theta. We have infinite number of points, so the net electric field E will be the integration of dE cos theta from 0 to 2 pi a, that is the circumference 2 pi a. Now you have to find cos theta here. So in this diagram you have, in right triangle is APO, you have cos theta is equals to x upon r. Thus we get cos theta. What is the value of electric field at point P due to charge at A? Electric field at P due to charge at A is, charge at A is dq charge. So electric field E, dE is equals to k dq upon r square. You know that lambda equals to dq upon dl. So you have dq equals to lambda into dl. Put the value at this point. So this is equation number 1, this is equation, no, let this be equation 1, okay. This is number 2 and this is number 3. Put the value from equation 2 and 3 in equation 1. Put equation 2, 3 in 1. What do you have? You have E equals to integration 0, here is 0, okay, 0 to 2 pi a, and the value of E is from here, this is k dq upon r square, and here the value of cos theta is x upon r, and at the place of dq we write lambda into dl. So the next line is k lambda dl x upon r cube integration 0 to 2 pi a. Now let us take the constant terms outside. What are the constant terms here? They are k, lambda, x and x r cube. So take out k lambda x r cube. So you have 0 to 2 pi a dl. Integration of 0 to 2 pi a dl is 2 pi a. What is the integration? This is 2 pi a. So you write this is k lambda x 2 pi a divided by r cube. Just we have written the formula which we get. You know that lambda is equals to dq upon dl. If dq is q is the total charge, you know, then dl is 2 pi a. So from here q is equals to lambda into 2 pi a. So at the place of here lambda 2 pi a, lambda 2 pi a, we will write q. So therefore electric field E equals to k qx upon r cube. R cube from board, r is r square a square power half. So put the value. This is k qx upon r square plus a square power 3 by 2 electric field. So this is the equation for electric field at point P. Now there is a special case that suppose P point is very far apart. It is special case. Point P is very far apart. Then you have a square is very less than r square. So a square is neglected. So neglect this a square. So what you get? You get E is equals to k qx r square into 3 upon 2. Cancel this. So you get k qx divided by r divided by, here is x. Here is x. Here is x from board. See that this is x is here. So it is x here. So we have x cube. Now cancel this x. So you have k q upon x square. So what you get? E equals to k q upon x square. And this is the electric field due to a point charge. This means that a charged ring produces electric field equivalent to a point charge when the point is very far apart from the axis of the ring. Thus you understand what is continuous charge distribution and how to solve problem on them. Do like, share, subscribe my channel. Thank you.